Hi everybody, I'm back from Mexico, so it's time to go through the last couple of episodes here and kick us to the end of the multiplayer networked version of the TextWorld. So when we had one player, time was turn-based. So every single time the user types a command, all the entities in the world had the opportunity to do whatever actions they want to do. With a multiplayer system, that doesn't make sense anymore because you don't know when people are going to be typing, how many people are going to be logged in or out. So the text world itself needs to have an independent stream of time where, say, once every 3 seconds, all the creatures have an opportunity to act. So, and that happens independently. So as we've learned already, for things to happen independently, they need to be running on their own thread. So what we're going to do is have the level class implement runnable, which is the interface that will let a thread run it. So what it means to implement runnable, as you remember, is to implement the run method. So here in my run method, I have an infinite loop because I just want the game to be running continually. And what's happening in the loop is two things. First, I update all the creatures, and then I sleep the thread, which means we just sort of wait for a certain amount of time before going back to the top of the while loop. And what happens right now in update all creatures is I just loop over all of my autonomous things and have them move and act. We could put other things in this loop, and probably will before I'm done here. And then to make it easy to change how time flows, I define this constant up here at the top. 3,000 milliseconds is 3 seconds, which is maybe a little bit fast. I might make it 5 seconds. And then once we've done that, all we have to do is change main to start the world running. So here in main, I've got my level object, I've got my parser, which is where I put all of the code having to do with parsing the user commands. Your user command parsing might be here inside main, and that's fine. But anyway, so I have level and I have the parser, and then right here is where I actually create a new thread with that level object and tell it to start. And when I run the start method, you might wonder, like, I'm not running run. The start method actually sets up the thread and then runs the run command from this runnable object. So the world is now running. Meanwhile, we've entered this do while loop here, which allows the user to type their commands and then asks the parser to parse the command into a command object and then tells the command object to do whatever executing needs doing. So that should be it. I would probably, if I were you, give that a little try and make sure that works before we start getting the network stuff involved. All right, so let's cobble forward. Let's create, so you might notice that I have all of my classes separated into different packages. So I have a commands package, which covers all of my commands, and a creatures package, which covers all of my kind of moving things. Oh, does my player not extend? Well, oh, it does extend creature. Okay, that's fine. I don't know why I kept it out of the creature package. Anyway, so let's create a new package for network-related stuff. So I'll create a new package, which I'll call net. Let's put it inside TextWorld. Great. And what I'm going to do is I'm just going to move over all of the classes for the last version of the client server exercises we were doing. So it is the kind of multi-client one, but we're only ever going to use one of the clients. Or rather, we're only going to connect with one client, and we're going to kind of leave it undetermined what happens if there's more than one. And then once we're happy it's working with one client, then we'll think about what do we need to do to make it work with multiple clients. Okay, so if I'm not mistaken, I think I can just drag this over here. Okay, let's maybe copy paste it. I think it was trying to make a reference to the file in the other location. All right, so I'm going to copy that, and now let's just copy all of them, and we'll paste all of them here. Yes. And hopefully that's all working. Did it add? Okay, great. And so it's taking care of adding the package to the top of all the files and so forth. All right, so formerly, main was the class that was kind of the main one that sets up the level and the parser and then has this loop which handles the user requests. So this is the same kind of stuff that we now want to be happening in the server. So let's try and figure out kind of which parts do we want to move over to the server. Okay, here we are on the server. Let's go ahead and remove all of this silliness with the names and the adjectives so that we can add some more silliness of a different variety. Okay. So to keep it simple, let's start moving things over. So we'll have the level and we'll have a parser. Oh, I promised. Okay, so I'm thinking all sorts of things right now about what this is going to have to look like once there are multiple players, but let's intentionally not think those thoughts because there's so many different ways that this might end up getting reorganized that I think maybe it's not worth our while to think about it right now. At least not in like a narrated video. Like, you know, sitting at a whiteboard, if we had an hour, that would be a nice way to consider the different possibilities. All right, so we've got our single static version, or rather variable for level and parser. Then I made this init and start level method where it's got all that same code from main where we create the level and so forth. Back here in main, after we start the world running, now we have the part of the code that's about like prompting the user for what they want to do and then handling their replies. And so this seems more appropriate to place not inside the server, but maybe inside like parts of it could go inside the client and parts of it could go inside the client handler that the server creates whenever a client makes a connection. So I've opened client handler. Let's figure out what we want to take out of here. So for the moment, we can leave this in, I think. We just won't think about it. But let's remove all of this inner stuff. So this is all of the like handling of the requests. And then that's fine, and that's fine, and then I guess we can leave that. That's fine. All right, so let's paste what was there before. And this will need a lot of changing, I think. Okay, so this part is about what the user types to the keyboard, and that doesn't go in the client handler, that goes in the client. So let's get rid of that. We're getting the player from the level, and obviously when there are many players, this is going to have to change significantly. We display the full description, which is all the information about the room and the items that the player's carrying and all that, and then ask them what they want to do, and then wait for the response. So this, like this asking them what they want to do and so forth, that should all go inside the client. This line where they type something, where they were typing something into the keyboard, that's now going to be whatever gets read by that input stream buffered reader. So let's do this. Let's make the minimal changes we need to make in order to have this function. And it's going to be kind of bad design for a little while until we kind of wrap our minds around what's it going to look like. But anyway, for the moment, we're missing level. So let's make sure all client handlers have access to the level object. Maybe we'll just give them each their own reference to the level here. And we'll import it. Yep. And that'll be part of the constructor. Sure. All right, so now that we have access to the level, we can get the player out. Okay, so let's look at this now. So display full description. We've got a bunch of print line statements here, and that's not going to work anymore because the server computer is running this code. So print line is going to go to the console of that computer. So instead, maybe let's refactor this by having this return the string that's going to be displayed so that way the client handler can send that back to the client. So I'm just going to do that right now. Okay, so here's what it looks like now. Looking at this, this is actually, we must have written this before we did a lot of refactoring because this is quite ugly now. This is really the wrong place for all of this code. Like a red flag should be, this method is inside the room class, but then we're getting the player and asking for the room that the player's in, and then displaying stuff about that. So that's like very bizarre that we would be displaying stuff about a room that might not be the one that's running the command. Like that's an indication that this really belongs somewhere else, because this method is not really intrinsically about a room. It's really intrinsically about a player. Anyway, so we'll get to refactoring that. But not right now. So let's go back to the client handler. So here we are on the client handler. So I'm going to call it prompt is the name of the string because it's like the prompt that we're going to show to the user. And then let's add to the end of the prompt this thing. What do you want to do? \n. And then we want to send that over to the client. So if you remember, out was the name of the print writer that's connected to the client. So we can say out.println prompt. Great. Oh, but wait, let's pay attention to what loops we have. So I had pasted the do while loop that we'd had before, but actually this getting of the player and well, let's back up. So this infinite loop here starts with us reading the input from the client. I think maybe what makes the most sense is to up in the constructor, let's set the player object. And let's do that first step where we get the prompt and we output it to the player. So sort of that's the first thing that the player sees. And now we can have this infinite loop where we read in their thing. And now there's no do while loop here. And now this in.nextLine, it used to be reading from the keyboard. Now this in.readLine is reading from the socket connection to the client. So this is whatever they typed. That's their request. So now all we have to do is kind of handle their request and display whatever the output is. So let's give every client class access to the parser object. In the same way that we did before, we'll just pass it in the constructor. Oops. And instead of response, which came from the keyboard, request is now the input from the client socket. Let's fix the formatting. And so the parser will parse that as a command, and then we'll tell the command to execute. And then I guess we can, there's no more system.println. Now we're using out, which was the print writer connected to the client. So we'll do that. But let's think about this for a second. What is actually going to happen when we run the execute of the various commands? So let's look at some of the commands, like for example the look command. So is this still going to do what we want it to do? Well, definitely not. So when I refactor the display full description, this no longer prints things. This returns a string. And this is still going to work. We're going to ask the level to get the player, and right now we're still imagining only one player. Here, So I guess the main thing that needs to happen is each of these commands before inside execute would have a print line, but now it needs to actually send the output to whatever print writer connects to the player who is executing this command. So let's refactor. Before, when we had this problem, instead of using a print statement, we would return a string that is what we wanted to display, and then we'd let whoever the calling code was decide what to do with that string. That makes less sense for the execute command because execute might have a whole lot of text that needs displaying, and we still want it to return Boolean for whether or not the command was successful. So instead of that, I think what would be better is instead of saying system.out.println is if we just said something like this, like player.println. Oh, the player is called P here. Okay, so p.println, where every player object has a print line method, and what that does is it takes a string and it will send that string over whatever unique unique print writer is connected to that player. So in other words, once the client handler gets the player object, I think the client handler should give the output print writer to that player object, and then everything that gets sent to the player will be through p.println. I mean, we can still say out.println here, but it could be p.println. So let's do that. And that's definitely going to change at least one more time before we're through with all of this, but I think that's going to make sense as a kind of a short thing to do right now. All right, so let's do it. We've got the player. So let's do p.set print writer. Let's create that method inside player. Okay, interesting. So because I'm doing it inside creature, which is my abstract class that player extends. And that's an interesting question, whether or not we would want creatures to be able to have this kind of thing. I think right now the answer is no, but in the future there's going to be some version of that that might be interesting for us to consider. For the moment, they'll let me just find player itself. Okay, here we go. All right, and it's not going to be abstract. And it's going to be private print writer out. Sorry if that was too small. Okay, so public set print writer, great. And now we'll say this.out equals out. And now we also wanted this print line method, right? Let's have it return Boolean. Well, I don't know, we can think about that. Message, and so now we'll say if out doesn't equal null. And I think it's a good idea to do a null check there, because if nobody ran this setter method, then print writer would be null, and we wouldn't want a null pointer exception to occur. So if it's not null, then we'll do print line message, and then we'll return true, otherwise we'll return false. All right, so back to the client handler. So every client will get the player, will set the player's print writer to be that particular connection. And then, so now instead of saying out.println, equivalently I could just say player.println, and that would do the same thing. I'm going to rename this player instead of p. All right, so where were we? Oh yes, so we were at this problem of like what's execute going to do for all the different commands. So now the various commands either have a player already, or my commands anyway all have access to the level object. So I can do something, right, so here we've already got p, which I'm renaming as player. So now instead of this, we'll say player.println, player.println. And that should just work. So I'm going to go through now and make that change in all of the other commands. And if I come across anything unexpected, I'll pause the video and talk about it. Okay, it's not that unexpected, but in the add room command, I have a level object, but no player object. Oh, is this getting inherited? Boy, messy. But remember, our level right now anyway has a getPlayer method because there's only a single player, so I'll just say level.getPlayer.println, and so that'll do the same thing. Here I am back in the look command. So as you recall, this now returns a string, which I'll call description. And now I can say level.getPlayer.println description. Okay. That was just a little bit different, so I thought I'd show you. Okay, so I've made all the changes. So hopefully that will work now. Let's double check the client itself. Right. So the client itself gets a connection to the server, and then it's got its own loop here. So we'll need to look at the server connection separate thread to remember what it's doing. But right now we're just in an infinite loop where we prompt the user with this little caret, and then whatever they type. If they type quit, we'll quit. Interesting, but we'll need to actually tell. Yeah, we'll actually want to tell the server about that quitting. So let's put that on the other side here. And then we'll break out of this loop if they've quit. Yeah, we'll think about quitting in a minute because that might have some other special stuff involved. Okay, so let's look at the server connection. Right, so as you remember, the server connection has this infinite loop where we just read whatever it is that the server has sent us. And if the server sends us null, that means that the stream is done, and so we exit. I don't want to say server says anymore, though. We just want to display whatever it is that the server has returned. And last of all, oh yeah. So back here in the server, remember we added all of those inputs to the client handler, and they were the level and the parser. Okay. I think we're getting ready for a test here. All right, so here I am at the server. Let's run the server. Oh yeah, well, that's no longer appropriate. Oh yeah. So your implementation may not have this, but whenever the creatures move, I have them display their movements. And this is the server console. And so it's probably actually not very helpful to see where the creatures are on the server. But the reason it's doing that is because that's I'm using system.out.println, and server is the one running the world, so that's where it prints to. Okay, cool. Well, we may want to take a look at that in a second. For the moment, where am I? So client. So let's run the client. Great, and so it already says you are in the hall. You aren't carrying any items. Items in room lobster. There are other creatures here. Pop star. Adjoining locations are closet, bedroom. You can type blah, blah, blah. What do you want to do? Okay, so what I want to do is I want to look again. Okay, same thing. I want to go closet. So that doesn't seem to have done anything. So that's something to look at. Let's look again. Oh, okay, so it actually did move me to the closet. It just didn't display anything. So that's something to fix. Let's go back to the hall. Oh. All right. Well, I wanted to try to take the lobster. Well, let's try this. Let's take the lobster, even though it's not present, because it should tell me, yeah, there is no lobster here. Great. Okay. So generally speaking, this seems to be working. There's clearly a couple of bugs to fix, so I'm going to go back and try and fix them, and then we'll start the really big refactor to think about multiple players. All right. So let's investigate that bug. So here in the go command. Execute. So if you can't go to a room, it will display that to the player. Otherwise, okay, but we're trying to move to neighboring room here. And what that does is it asks the room if it has the neighbor, and we get the neighbor. Okay, so yeah, it doesn't display anything. It just moves to the neighbor. So the reason that we didn't see anything is because, in fact, there was nothing to see. So that's easy enough. All we have to do here in execute is print line, you have moved to the, or you have moved to, and then room name. All right, great. Okay, so come back. I'm gonna make a new video. Come back next